You know how to scale an object. You know how to move it, forward and back. If you change its size, well, you can just go like this. If the cube was 1 unit high and you need to make it double that size, we'll just make it double that size. Use the same VPs, use the same everything, but you just can take a height and double it. The only thing I haven't shown you, I've shown you how to rotate a cube. There's one more key thing that I have to show you, and it is probably the densest. Well, I don't want to intimidate you because it's really not that bad, but this is the most challenging thing we're probably going to do the first few weeks of the semester. If you can own this, and actually, this is a perfect place to say this. I said at the beginning of class that first you drew the forms, now we're figuring out the relationships between the forms and how to manipulate those forms. If you get through this week and understand this stuff well, you're going to be in great shape. That's all this week is about. Your homework assignment is to go home and do these 5 cubes, and I'll detail it in a minute. But you're going to do a mechanical drawing of 5 cubes, rotated, moved, scaled, and all this kind of stuff. If you can draw these 5 cubes correctly, by the end of the day, Wednesday, you are going to be fine. Okay? Now what's going to happen is your homework assignment is going to be to go do these cubes. About 25 to 30% of you will probably do it perfectly. You'll probably nail it. You'll have, your drawings could be a little cleaner or nicer or whatever, but technically, mechanically, they'll be fine. The other 70% of you or so will have some kinds of problems, but they probably will be minor, like, your vanishing points were a little bit too close, or what do I do when my vanishing point goes a long way away, or, there'll be things that happen that we are going to spend Wednesday talking about, all right? There will be maybe about 20% of you that get hopelessly messed up, As long as you come to class with your questions, and we're going to be going over all this material again on Wednesday, so to cement it into your brain, you'll be okay as long as by the end of the day you've got your questions answered and you know what you did wrong. All right? Because really, this is the foundation for like the next 12 weeks of the semester. Is if you own this cube and you know how to move things around, you guys, to give you an idea, all you do to make a cylinder is draw circles at 2 ends and connect them. All you do to make a cone is put a dot on top and a circle at the bottom. Everything is based on this. All you do with the sphere is just draw a bunch of ellipses and make a circle out of it, and you've got the sphere. So if you own the cube and you know how to move it around, you actually know how to do that to every solid, every form. Now, so let me show you this one last thing, and then I'll go into the homework assignment. So this one, again, is probably the most complicated mechanical drawing we're going to do, so I'll go a little bit slower, or I'll make sure you guys are understanding. Please ask questions if you don't understand what we're doing. These first few things that I'm doing are arbitrary. Now you guys notice to find the station point, I'm going to do this and find a 90-degree angle somewhere in my page that goes to both vanishing points. That's a 90. What? Oh, thank you. All right, now I'm going to draw a cube somewhere over here. I'm going to draw it here. Actually, maybe it's a little bit lower than that. I'll draw it a Now, I can do all of this because it's completely arbitrary. Okay, the length of the cube or the height of the cube, all these things. Now, once I get to this point, the only other thing I can really do is this. I can draw guidelines for my cube, or for the front corner of it. All right, but does anyone see the problem I've just hit? What? Can you? They're not equal. What it comes down to is these are not equal amounts of foreshortening, and so I have to find, well, I know this has to be 1 unit, but how far is 1 unit? You see what I mean? I don't know because these lines are unique. All right? Now, here's what I'm going to do to address this. Let me sharpen a pencil real quick here. I'm going to draw a line here. And I'm going to call it measuring line 1. Now you guys take a look. So I've got the compass, and I'm going to take the compass and I'm going to transfer the height down to the measuring line. So these two lines here are equal to that line. I basically just did the thing we did at the very beginning of class. I'm taking the height and I'm going whack and whack and dropping it to the side. Now take a look at this, you guys. Everyone eyes up for just a second. So notice that I can do this. Eyes up. I can drop it here, but now I have to do this. You know, so I could drop it vertically, but now I have to foreshorten it. Now the thing is how much do you have to foreshorten it? Here's the formula that I want you to memorize, and I apologize for it looking like an algebra class. There's a reason behind it, but memorize that. All right, and I'll show you what it means in just a second. Okay, so everyone stop taking notes for just a minute. I'm gonna have you stop for about a minute and watch me do I'm gonna draw the side. I'm gonna draw this side of the cube. And then I'll let you catch up on your notes. So everybody stop taking notes. Pencils down. Okay. So what this equation means, or the reason I want you to memorize it, is I basically want you to do this. I need to find. Actually, let me do it a little bit of a separate drawing here. Hang on a second. This is actually a better way to explain it, but I hadn't thought of it until just now. Imagine this is our measuring line, okay? And imagine our corner is doing something like this. those are square sides. Okay, so we could actually. So this distance here and this distance is equal to this distance and this distance. You with me? But now, watch this. Do you see that there's only, if I draw from here, this line is going to BP1, and if I mark anywhere other than this one spot, it's not going to be the right length. So I've got this line going to VP1, and I basically want to come in and go and chop it with a cleaver, right? So let's go back to this. So I have to find a line that's going to cross here in exactly the right spot. This is how you find that point. Okay, everybody watch. No notes for a second. I go from the vanishing point to the station point. If I now draw a line to this point, it'll cut off this line in exactly the right spot. Watch. Okay? Try to do that, then try to do the other side. What was that, Ashley? What? Well, you know, in all honesty, I've used pieces of paper, I've used credit cards, I've used my fingers. Remind me one of these days when we have extra time, I need to show you guys the eyeballing test. Did I show you guys the eyeballing test? That online thing you guessed.
Oh, that's the first thing we were supposed to do.
Take this.
Oh yeah, that's right. That's right. My brain's fried today.
Yeah, well, they
And
could
24 only.
it would be something they could do that'd be better
I
than
can
picture.
draw dots and make lines and things. I'm good at that.
I heard that. I heard that. You know, that's the problem with being an artist. I'll do things that are just, it drives my wife crazy because I'll get interested
The
in
area that
something and I'm not
intersects on the
doing it
line is
for
the
money.
part where we
I just want to
draw in the square,
And
right?
it's like, oh my God,
Yeah.
look at that.
That's what I thought.
But this is cool. It's funny because I'm pretty much a practical thinker most of the time. But when I get on the movie stage, I have a hard time. All right, so you guys, now I'm going to do the other one. See if you did it correctly. I'm going to measure from vanishing point 2 to the station point. Swing it up to the eye level. Mark it as measuring point 2. Draw from the measuring line to measuring point 2 until I cut it off right there.
So that is the measuring point. It's not labeled down here. So this
Voila. Now at this point, you guys see that you can finish the cube and you're good to go at this point? What was that?
I said it looks right. You finish it, it looks right.
Are you?
I just said you can finish the cube and it looks right.
Yeah. Well, actually, kind of. Usually, what happens? Another thing that happens to you guys sometimes is people will do it and they'll go, "Okay, it doesn't look right," and I'll say, "You know what that is? That's actually, you know how when you're doing your cubes and you think you're right and it turns out you're wrong." All right. Well, the degree to which this looks strange is the degree to which your sketched cubes are wrong. Because this is dead on right. This is spot on right. And so if you're looking at it going, God, it looks a little too tall, or it looks a little too something, well, that's your brain. Like, not wanting to admit that it's not seeing things very
Just
accurately.
put a dot here.
You know, but this is
Right
correct.
here.
Yeah.
We did this one and then we moved up here.
Yeah.
And then this is supposed to
And what will
intersect with
happen is
this
as
line,
you
right?
do both,
Yeah,
as you
and
go
that
back and
determines your
forth between
vertical.
mechanical
Okay, it's still
cubes
wrong.
and sketched
Um,
cubes,
And
the
then to make
differences
your diagonal
between them will
backs,
become,
you go back to this
you know,
plane.
less significant. They'll start to improve each other, kind of. You're looking at better cubes, so you know you start sketching cubes better and vice versa. Question?
Yeah, I wanted to know what's the significance of the MPV, the second one.
MP2. Oh, I'm sorry, MP2.
Sorry.
What's the significance of it?
Yeah, how can you use it? I just.
Okay, here is the thing that I want you to understand. Think about it this way. Everyone's just kind of do a mental experiment for a second. If you have these lines, if I change the angle of that line, I need a new, you know, what we're doing is this line right here is going to MP1. This line here is going to MP2. Right. So, do you see that if I rotate that cube at all, that square at all, these lines have to change with them. If suddenly this line's going out here, well, now I need to draw a line like that. You see what I mean? So what it is for every line that's going to a vanishing point, every line going to a vanishing point will have its own measuring point. Every VP has its own MP. All right? Because only one line will cut it off proportionally, correctly. Now, let me do one more. I'm going to come back to this in just a second because I want to show you why it works, which may make some things understandable or may confuse some of you guys. But were all of you guys able to do this first? Okay. So at this point, if I asked you to draw another cube into this scene that was the same size, do you see that you could start, everyone will look up, do you see that you could start by saying, okay, well, I want a cube here. You could scale it. So you have the vertical. Draw another measuring line so you can go boom, boom. Have that. Then you need to say, oh, I want to rotate it. So you would go like this. Do I want to rotate it that way or this way? Oh, I want to rotate it this way. Find the new vanishing points. Find the new measuring points. Repeat. Rinse. Repeat. Rinse. What was that?
So you draw the measuring line first before.
You wouldn't have to, but I probably, it doesn't matter actually. My point is this. If you can do five cubes that are rotated and scaled in different ways in the same picture, and if you can get through that, it's a little bit like laying down 5 bricks by 3 rows high. So it's like, okay, I can lay in these bricks If you can do that, you can build a wall,
Should be going.
right? If you can do that correctly. It's not any harder to build the wall, it just takes more time. You know what I mean? So when you get into these really complex drawings, like these super complex drawings that you guys have seen, like some of the Cube City stuff and all that, those aren't hard, they just take more time. It's not any harder than doing this. You just have to do it again and again and again and again and again and again and again. You know, and yes, it feels that repetitive after a while. But you will also get faster, you'll know how to take shortcuts after a while. There are things you can do to alleviate that. But really, if you can get through tonight's homework assignment, you know what you need to know to do these super complex drawings. Okay? You just have to have the patience to do them. All right? Now, let me show you one additional thing why that works, and then I'll show you the homework assignment. So, if this next thing that I do goes over your head, okay, don't worry about it. All right? It's not a problem. But for some of you guys, in my experience, some of you will see this, and it will be kind of the, oh, now it makes sense. All right. So imagine I drew a measuring, imagine again I have a top view down here. And I'm going to take my compass. So I've got my top view. And I have the same thing that I did here, essentially. Okay, watch this. If I draw a line here, okay, watch what happens if I take this angle and I draw that angle at the station point. That angle, well, not quite right. I was a little off there, but that's why it works. You're taking that angle, and these essentially become the vanishing points for these lines that properly cut off the geometry. Okay? That's kind of bonus material. You don't really need that, but in my experience, about half the class will react to what you guys did. Oh, well, why didn't you say so? You know, and the rest of the class is like, I have no idea what you just said. All right? Okay, here's what I want you guys to do for the homework assignment. On marker paper, 11 by 14, yes.
Oh, just a quick question. The short red line, where is that going to?
It is going from this segment to this segment.
Okay.
So it's just that I want to find this angle, whatever it is, and then that's reproduced here.
Okay. So it's not going to like
It's not
eventually.
going, no.
Okay.
No. It's again, you have to imagine we're doing this. Take a look. You have to imagine we're doing this, and that's the top view. Here, if that confused you further, don't worry about it. It's not a problem. Yeah.
So is the station point always going to be 90 degrees there?
If you're drawing a 90-degree object, yes,
Yeah.
which is 99% of the time.
Okay.
You know, so it's going to be 90 degrees 99.99% of the time. How about that? To say it in a really confusing way. So your homework assignment on a sheet of marker paper, 11 by 14. I want you to draw an 8 by 10 rectangle on that sheet. And I want you to draw 5 cubes within that rectangle. I want them all to be in the cone of vision. The first 3 cubes I want to be the same size. The 4th cube, make it half as big, and the 5th cube, make it twice as big. Of the 5 cubes, 2 of them can share vanishing points, meaning they can be parallel to each other. That'll save you a little bit of time. The other 3 cubes, I want to have unique vanishing points, meaning they're rotated in a way that they are not parallel to anything else. I want you to do it mechanically using the mechanical tools, okay, as necessary. I want you to try and do it nice and clean. We'll talk about, one of the things we'll talk about on Wednesday is the differences between the mechanicals and how to clean them up so they're more effective. Some of you guys will be a little bit messy this time, and you'll barely get through it doing 5 cubes. If you try and do a drawing like that with much more complexity, there's no way you make sense of it. So we'll talk, some people though will have really nice ones, and we'll talk about which ones look nice and how to emulate them. So basically try to do that drawing. If you come in with that mechanical, when you come in, I'd like you to mount it on the wall with, meaning tack it up. Tack it up on the wall, but tack it up with a piece of white paper behind it from your drawing pad so that we can see it clearly from a distance. And that's that assignment. Okay? Yes?
Is it all going to be done in graphite?
Yes. So that's assignment number 1. Assignment number 2 is fill out your peer evaluation and turn it in. Follow the instructions on the website and from earlier in class. Assignment 3 is finish your grayscale, because we're going to be critiquing those in class on Thursday, sorry. One other assignment. It's a week from today, you guys are going to be turning in your first real cube rendering. Okay, where you do it like the one I showed you that looked all pristine and wonderful. Okay? That'll be due a week from today. I don't want you to spend hours rendering something that isn't correct. Okay? So what I want you to do is this. Everyone look up for a second. I want you to do one additional mechanical of a single cube in the corner of a room. Do it at full size, so like you'll have, do it on, tracing paper. You'll have a 4 by 5 inch rectangle on a, it's the same proportions as before, so a 4 by 5 inch rectangle. And essentially what I want you to do is I want you to do a mechanical where this entire thing is in the cone of vision, and let's say you end up with something like this. You draw a cube. And then you put it in the corner of a room. You can do different vanishing points or the same vanishing points. Okay, but put it in the corner of a room. All right. Now there's one additional thing we're going to do on Thursday, which is I'm going to show you how to do the geometry of shadows. But that's not a big deal. It's a piece of cake. We can add that between. You can add that to your cube after Thursday. Okay? But do this mechanical, and I want you to be able to put it up on the wall because I want to check it and catch any mistakes you make before you start rendering the hell out of it.
You want the choosing paper version?
Yeah, basically I want the line drawing, the mechanical. Yeah, on Thursday. Does anybody have any questions? Do not shape, no, I just want the line drawing and have it set. What?
Do not spend 20 hours on it.
Yeah, well, I mean, honestly, like, at this point, well, you know, here's, in all seriousness, you guys, this is something I would like you guys to try. We're a little bit early. You know, it's funny because the morning class went right to the limit. The afternoon class finished 20 minutes early. We finished about 15 minutes early. Here's what I'd like you guys to do. We've got about 15 minutes. Try this. Now, without your notes, oh, actually, that's what I forgot to say something. Hang on. Wait, I just remembered something I forgot to say. Here's something I would strongly encourage you to do. Oh, and I just remembered in the assignments. Don't worry, it's like the final one. Look at, you know, most of you guys probably have lunch and then another class or something like that, you know, maybe even a couple before you go home. If you get a chance in the next, say, 4 or 5 hours, you know, you're sitting there at lunch, you know, detoxing, you know, or mellowing out. Okay, pull your notes out and just look at them. Just look them over. You don't have to do anything with it. Just kind of look them over and make sure you think you understand them. Go home tonight, eat dinner, relax a little bit. Pull your notes back out, look at them again. Tomorrow morning, do the same thing over breakfast, or do it, you know, like, this is a subject you need to study. Tomorrow night, as you go to start doing the assignments, pull them out and redraw them. You know, for your notebook. And actually, that's the assignment I forgot, is sometime in the next week or so, I'd like you to take some of these initial notes and make 2 or 3 notebook pages out of them, just so that you can see how it's going to work doing these diagrams. And in about a week or so, I'm going to ask you to bring those pages in so we can critique them under the downshooter, so people can steal good ideas from each other. Yes.
I noticed that you were labeling the diagrams that you were drawing. Are we going to be able to see your diagram somewhere?
What we're going to do is at the end of the semester, I'm going to give you a list and say, this is the minimum you should have in your notebook. You know, these diagrams, and it's going to have a list, and you should be able to go check. Yeah, I got that one.
Should I be labeling in my notes what you're labeling?
No, it doesn't matter. I can, when I grade the notebooks, I'm looking less at what you write unless I see stuff that's obviously wrong. I'm looking less at what you write and just going, oh, yeah.